I will take you through this Kaggle assignment. It is regarding the reviewing of the feedback on the movies. So we have been given 3 files. If you see in the given dataset, we have train.csv file, test.csv file, and the sample submission file. So the train dataset is something like this. We have the phrases. There's 3 features are there, and then the sentiments are there. Of course, ID is also there. So phrases can be some of the text, right? And with phrase and the features, some kind of the sentiment has been provided to each of the row, right? So sentiments are 0, 1, 2. So if we see what kind of the data set has been provided to us, we can see the number of entries, 7,000 entries are there. We can see which features have not null values, which features have null values, what is their data type. We can see the statistics of the data set. We can see what all null values are there and fix that null values in both training and test data sets. And then we can also fix the outliers. So you can check the outliers using the box plot visual, and also you can also see the distribution of your numerical columns, right? Using the histogram plots. And IQR is interquantile range is one of the methods to figure out the outliers. So we can use the interquantile range method also, and then we can fix the outliers, and after that we can also show how many the number of the features are there, how many outliers are there once we have fixed them. So if you can see, there are outliers in our 3 columns, and after we fix them, then there is no more outliers. After this we have to, because if you can see in our data sets, we have if you see in the features 1, 2, 3, there are some null values that we have fixed, but here you can see they are at these column values of the different sizes. For example, some are feature 1 has 37 value, 20 value, whereas the feature 2 has 1, 2, 3, 4, 5 values like these. So if we directly give in this way to the model, then maybe the feature 1 will dominate. So we have to scale them on the same level. So how we are scaling? So we so we will use standard scaler to scale these values. And also I would like to tell that here, if you see in the column related to phrase, so we cannot use one hot encoder here, because it is not just a few categorical values, right? It is a total text. So we need some way whereby this text can be converted into the vector, right? So each of the row can be converted into each of the text in the row for the phrase column can be converted into the vector. So there are various ways to do this thing, like TD-IDF is one of the way. Then there is Uh, then you have BERT is also a way. So TDIDF has its own on pros and cons, and in this context, cons are more. So we have gone for the BERT, bidirectional encoder representation of transformers. So if you can see here, um, we have use this transformer, and we have load this BERT model. The model we are using, it is something which is pre-trained, so we don't have to retrain this thing. And here we are doing, in the text column, we are doing the embedding of the BERT. Okay, so this is the embedding process has completed. After that, if you can see, this we have created one, after embedding for the phase, we have against the phase, we have created one new column, BERT embed, and we see it is kept in the vector form. So once we have done this, what we are doing next is numerical column scaling we are doing, and then this thing we are putting in the feature matrix. And same thing we are doing for the test data set. Once we have done this, we are taking 7 models. If you can see, we have taken the models like logistic regression, KNN decision tree, naive Bayes, random forest, and few of them we have hypertune also, like random forest, XGBoost, and SVM. These classifier models are there. This logistic regression model is taken, but it's fine, but it should have to be the logistic classifier would have been taken here. But anyway, so here one of the thing, so if we use gradient boosting classifier, so it will take a lot of time. So we need a kind of we need to go use the GPU. So for that we have also used the XGBoost instead of gradient boosting classifier. And after defining our models, we have trained these models and evaluated them. You can see, yeah, so here you can see all these models accuracy scores. You can see the accuracy score of the SVM is highest among these, and after that we have just predicted the Y values, that is sentiment values, on our test data set, and make the submission data frame with respect to the given format, IDs of the test data set along and the predicted sentiment values, and we put it into the submission.csv file, right? And the file we have received, this we have in our Kaggle platform, we have submitted this value, and our score that we were getting was if you see here, submission score is 0.63. So 63% accuracy is there in our model. Right. That's it. Thank you very much.